Okay, now, dear friend, I will solve question from practice 5C. There are 3 questions and all same. If you understand the second, it is the second question. I think I have written here 5, but it's 5C, second question. If you understand it, you can solve the others. It's a long, it has a long solution. So let's start it. Mass of car is given. Mass of car M is equal to 2,500. 2,500 kilogram car traveling to the north. To the north. It is better to write the beginning. We need it for calculation. To the north, and then let's continue. It's slowed down from an initial velocity of 20. The initial is given 20 meters per second. It slows down by a force 6,250 Newton braking force acting opposite the car motion. So force is equal to 6,250 Newton to the south. To the south. It causes car to stop or to slow down. Use impulse momentum theorem. It says in A, let's see what is wanted. In A, it says what is the car velocity? What is the car velocity after 2.5 seconds? We final wanted after 2.5 seconds. 2.5 seconds. So 2.5 seconds is delta t here. B, what is wanted? How far does the car move during that time? Delta x wanted again after 2.5 seconds. And in C, it says how long does it take the car to come to a complete stop? How long? Delta t wanted when the final velocity becomes 0. So let's start from the section A. Let's start from section A and solve those. The first one, A. F multiply delta t is equal to mass multiply V final minus V initial. If you remember, we wrote the given initial is 20 and final here wanted. Initial is 20 and section A final velocity wanted. So let's write them. Force is applied to the south, so I will take it minus 6,250. Multiply. Delta t is given as 2.5 second. 2.5 second. Mass of car 2,500. Multiply the final wanted. The initial is 20. So here we can make some cancellation, dear friends. 2,500 and 2.5. If we cancel to each other, this part will be 1,000. Then with this, by this 1,000 and 6,250, I can make a cancellation. This part will be minus 6.25 is equal to here we have only V final minus 20. So if I send 20 other side, it will be positive 20 minus 6.25 is equal to V final. Then V final is equal to 13.75 meters per second. This is the first part, A. So after 2.5 seconds, velocity will be 13.7. Let's see B, what it says in question B. It says what is delta x at that time. So delta x wanted in B. Delta x is equal to, from accelerated motion, we remember it, we know it, V initial plus V final delta t. This part is V average, yani V1 plus V2, V final initial plus V initial over 2V average. So V average multiply delta t. Delta x is equal to 1 over 2 multiply initial velocity 20 positive and final is 13.75. It is also positive. Multiply delta t. Since it says at that time is 2.5. So delta x is equal to 1 over 2 multiply 33 0.75 multiply 2.5, and delta x here will be around closer to 42 meters. It is positive because here it's moving to the right or north, we say, to the north, and here also velocity also to the north. And the last part, C now, section C, it says what is the time when it comes completely stop. Since time wanted, we use again impulse momentum theorem. C F multiply delta t is equal to mass multiply V final minus V initial. F given minus 6,250, delta t wanted, mass is 2,500. When it comes completely stop, final will be 0, so 0 minus 20. Minus 6,250 multiply delta t is equal to, if you multiply minus 2 by 25, it will minus 50. And there are 1, 2, 3, 0, let's add them, 50,000. If you divide each side by 6,250, 6,250, thus will cancel to each other, and delta t will be 8 seconds. After 8 seconds, the car will completely stop.